Hello there. We have been on a journey of exploring science, and the major part has been body systems. I know we are enjoying every bit of the knowledge that we are getting. So I want to move on. We are going to look at endocrine responses. Now, in our previous lesson, we have been trying to look at how body systems can be coordinated. And we said that because multicellular organisms are usually complex, because they are complex, they require a means of coordinating several body systems. So we mentioned two ways in which communication and coordination activities can be achieved in the body of multicellular organisms. We said it can be achieved through the nervous system and also through the endocrine system. So just to choke your mind a little bit, we have looked at the nervous system. We said that the nervous system is made up of specifically the neurons, and neurons are those structures through which impulses are transmitted. But that pathway through which those impulses will be transmitted along the neurons or through the neurons, we were referring to it as the reflex arc. So you can remember the reflex arc, for instance, if you step on a hot object, where there will be stimulation of receptor cells on the skin, specifically the pain receptors, and in the process a nerve impulse will be generated, which will flow or be transmitted through sensory neuron, through the intermediate neuron, and then through motor neuron to effector organs, and in the process a response will be achieved. So that one forms a platform for us to continue with coordination, endocrine responses. So when you talk of endocrine responses, one thing that should come in mind, what are the major factors that are involved? In the endocrine response, we are going to have endocrine glands. We usually have endocrine glands, and it is these endocrine glands that when there is a stimuli that has been detected, they are going to release, endocrine glands release hormones. So these hormones will be transmitted, or they are going to get into the blood, and in the process they'll be transported to the target organs. But one thing that we should know about hormones, they are usually produced in small quantities. They are produced in small quantities, and after that they will diffuse into blood. After diffusion into blood, the blood will now perform the role of transporting these hormones to target cells. So what we should know, there are two important ideas that we should get, that in the endocrine responses, it is going to involve endocrine glands, that upon detection of a stimuli, they are going to secrete hormones in small quantities. After release of the hormones in small quantities, hormones will diffuse into the blood system, the bloodstream. In other words, circulatory system. And then circulatory system will now perform the role of transporting those hormones to target organs. But we should be able to know that there are several processes in the body or conditions in the body that are controlled by hormones. Conditions in the body that are controlled by hormones include so one of them could be sugar level, blood sugar. Now, I know it's not the first time you're coming across this, that we have hormones that can control sugar level. We know those hormones. We have two kinds of hormones that control sugar level. We have insulin and glucagon. So we are going to find out, in our discussion, we shall find out how the two are involved. We also have other conditions like osmotic pressure. Osmotic pressure. OP is also controlled by hormones. One very important hormone that is involved is called antidiuretic hormone. In some literature, it is abbreviated as ADH. A for anti, and D for diuretic, and H for hormone. But in other texts, you will also find it being referred to as vasopressin. So whenever you find vasopressin, it means the same, antidiuretic hormone. Other condition could be ionic concentration. Ionic concentration. And the most important ions in the body that should be controlled are majorly the salts. So these are simply salt ions. And the major hormone involved is called aldosterone. We have aldosterone, and also we have cortisol hormone. So for ionic, we have two. Hormones involved will include aldosterone, as I've said, and another hormone called cortisol. Aldosterone is mainly involved in regulation of two kinds of ions. We have sodium ions and chloride ions. I think in your previous level, or even in chemistry, you know how to write those chemical symbols, those chemical elements using their symbols. That is sodium, that is chloride. But when you have positive and negative, it shows the ions, either positively charged or negatively charged. But for cortisol, is involved in regulation of calcium ions. So those are three major conditions in the body, although we have several others that can be regulated in the body. But now we have to find out what happens, or the pathway mechanism mechanism of endocrine responses. So for any response to be evoked, one thing that must be there is a stimulus. So there must be a change in the environment. That change in the environment will stimulate a gland to release a hormone. After that hormone has been released, it will diffuse into the circulatory system. Circulatory system will now take over the role of transporting the hormone to the target cell. But on the target cell, we usually have receptor structures. Those receptors are going to bind with the hormone. The receptors on the target cell bind with the hormone. And in the process, it is going to change the activity of the cell. That change in the activity of the cell is what we call response. Now we are saying the change in activity is response because, for instance, if you have a phone somewhere or in your house and you hear the ringing of the phone, you are going to respond. You'll move wherever you are. If you are watching something on TV, you are going to move. You have changed your activity so that now you attend to the caller. So that is one way of responding. So mechanism of endocrine response is very simple. We must have a stimulus. So what we are saying is this: a stimulus will be detected by a gland, and then a gland is stimulated. Gland is stimulated to release hormone. To release a hormone. A gland will be stimulated to release the hormone. But that hormone will diffuse into blood. Hormone diffuses into blood. For what purpose? So that it can be transported to the target cell for transport. To target cell or structure. In this case, the target structure is an equivalent of the effector. Is the same as the effector. After blood has transported to the target cell, the hormone binds. Hormone on reaching the target cell. Hormone on reaching the target cell, which is in our case the effector, is going to bind with the receptor. It binds with a receptor. With the receptor on the target cell. So the net effect is that the activity of the target cell is going to change. So this change in the activity of the target cell is what we call response. That's what we call the response. So we can illustrate this as a pathway. Pathway for endocrine response. Just like the reflex arc, which is a pathway for transmission of impulse, also endocrine responses consist of a pathway, just like we have said. So we are going to have stimulus. Remember, we said the stimulus is changing the environment. So the change in the environment, we shall use a specific example. So stimulus will be detected by a gland. A gland. Let us assume that gland has that structure, or endocrine cell. So that cell, but in that cell we have hormones. I'll use this to show hormones. Let's assume that we have hormones in this cell. So we have the hormones. After detection of the stimulus, this cell will release. It's going to release the hormones. These are the hormones. Those hormones will now get into the bloodstream. Bloodstream, we shall assume that is a blood vessel. So it diffuses hormones. These are hormones. Hormones now diffuse into the bloodstream. Or circulatory system. This is diffusion. This is release of the hormones. Then, as we have already said, after that, on reaching the target cell, suppose this is the target cell. This target cell has receptors. So those receptors are supposed to be compatible with the hormones. Receptors. So what will happen? That hormone is going to bind at that point. And that hormone, another one, binds at that end. When the hormone binds on the receptor, hormone are binding on the receptor of the target cell. What will happen? There will be a response from the target cell. There will be a change in activity of the target cell. So that change in activity of the target cell is called response. So it's very easy. Stimulus, change in the environment, and then detected by endocrine cell. Endocrine cell is stimulated to release hormones. Hormones diffuse into the bloodstream. Bloodstream will transport hormones to the target cell, where the hormones bind with the receptors of the target cell. And in the process, target cell changes the activity. That change in activity is what we call the response. We are going to use an exact example to follow all through this. So example of that pathway is this. Our stimulus, let us say there is high blood sugar, high glucose, high blood sugar. That is a change in the environment. That is a stimulus. High blood sugar. This is a normal one. 70 milligrams to 100 milligrams of sugar in 100 millimeter of blood. That's the normal one. But above that, it becomes a change in the internal environment. So that change in the internal environment will stimulate a gland. That gland is called pancreas. Pancreas. Pancreas will now be stimulated, which is the endocrine gland, and we have cells, specific cells called isolates of Langerhans, isolates of Langerhans. So isolates of Langerhans are specific endocrine cells in a gland, the pancreas. So the pancreas will release a hormone that will bring blood sugar back to normal. That hormone that brings blood sugar back to normal is insulin. So releases a hormone, insulin. So a hormone, insulin, is released, and then it will diffuse into blood stream. And then blood will transport insulin to target cell. That target cell is the liver. The liver cells. So on reaching the liver cells, insulin will bind with the cells, with the receptors of liver cells, and is going to change activity of liver cells. What are some of the activities that will be changed in the liver so that it brings blood sugar back to normal from high, to lower it? So some of the activities that will happen in the liver due to insulin will include conversion let me use this space. Conversion of glucose to glycogen. That's just one activity, conversion of glucose to glycogen, so that this glycogen will be stored in the skeletal muscles and some in the liver cells. So it will have reduced some slight bit of the glucose. And then conversion of glucose, blood glucose, into fats. Those fats will be stored as adipose tissue under the skin. Adipose. It will form the adipose tissue. And another activity of the liver to lower blood sugar is increase oxidation. It will cause liver cells to increase oxidation of glucose. So these are very clear pathway. High blood sugar is the stimulus, change in the environment, because we have a normal one. Above 90 milligrams of blood sugar in 100 ml of blood, that is high. it is going to stimulate isolates of Langerhans. These are the cells in the pancreas, which will release now insulin. Insulin lowers blood sugar back to normal. It's not going to remain in the pancreas, but it will diffuse into the blood. Blood will take over the role of transport. Then transports insulin to the liver cells. On reaching the liver cells, insulin will cause liver cells to do the following three: convert glucose to glycogen for storage in the skeletal tissue and in the liver itself, conversion of glucose to fats that will be stored as adipose tissue under the skin, or increase oxidation of the glucose. So these three can either occur at once or one or two of them, provided that is going to bring blood sugar back to normal. But most of the time, it is the conversion of glucose to glycogen and to fats, because already oxidation has taken place. Most of the glucose that was there for that purpose has been oxidized. So these two, the first two, are the most common one, unless it is too excess. So this is an example of a pathway through which the endocrine responses is going to take place. It could be an equivalent of a reflex arc. But now, if you look at it carefully, you realize that endocrine response, because there is diffusion of hormone into blood taking over to transport this hormone to target cells, you realize that endocrine responses are slower than, they'll be slow than for nervous system, because for nervous system, the impulses are confined within the nerve fiber. There is quick transport or transmission of nerve impulse to the brain, then back to the effector. So in our case, liver cells are the effectors. And then the duration will last longer for endocrine responses, because you realize that even this does not take immediately. It's going to take some time even to oxidize glucose. It's not a spontaneous reaction. The hormones will build up fast. After building up, as they build up, there's already some slower oxidation taking place. When they reach maximum, when hormones reach maximum in the liver cells, now it's going to bring about maximum oxidation of the glucose. Now, the question is, after these hormones, remember they are protein in nature, after they have been used in endocrine response, what happens to them? Do they go back to the gland that secreted it? That one does not happen. Once it is released, diffused into the blood, most of them, again, will be broken down by the liver. After being broken down by the liver, they will be excreted in urine, specifically through the kidneys. So they'll be broken down and excreted through the kidneys. So we are going to look at examples, several examples of hormones. Their gland, the gland that secretes them, the hormones that is secreted, and the functions of those hormones. So here we have a table of glands, hormones, and role of the hormones, function. So we shall have a table here, gland, that is, gland, hormones, secreted, and function. So one very major important gland is found in the brain, is called pituitary gland. Pituitary gland. Pituitary gland secretes several hormones. So the first one, we shall look at a hormone called Adrenocortical Tropic hormone. So it is abbreviated as ACTH. F for adrenal, then cortical, C for cortical, T for tropic, and H for hormone. So the word itself, or the name of the hormone itself, can help us identify the target organ. Adrenal gland. Adrenal gland is just found above the kidney. But the part of the adrenal gland that will be stimulated is the cortex, the word cortical. Then tropic means the upper part, and then hormones. So the major function of adrenocortical tropic hormone, it stimulates adrenal gland to secrete other hormone, two of them, aldosterone and cortisol hormone. Stimulates adrenal gland to secrete two hormones, to secrete aldosterone, we have another hormone, cortisone, and which is also called, there are mainly two. This one is also called calcitonin. So it is going to stimulate adrenal gland to secrete aldosterone and cortisone hormone. So this is just one hormone. It secretes several other hormones secreted by pituitary gland. We also have human growth hormone. Human growth hormone, abbreviated HGH. This one stimulates growth. Stimulates growth of bones and cartilage. But also causes development of cells, causes cell development, causes cell development. The other hormone is thyroid stimulating hormone. Thyroid stimulating hormone. Now, some of the names of these hormones can easily tell you what they are going to function. Thyroid stimulating hormone. It means it stimulates thyroid. And thyroid is going to release a hormone, adrenaline. Thyroid stimulating hormone. Thyroid stimulating hormone stimulates thyroid gland. Stimulates thyroid gland to secrete adrenaline hormone. Thyroxine, that is, not adrenaline, thyroxine. To secrete thyroxine hormone. Hormone number 4 from pituitary, we have follicle stimulating hormone. Yes, again, the way it is stated, follicle stimulating. Where do you find follicles? Follicles are found in the ovary. Follicles are meant to release ova. So it's going to stimulate the ovaries so that they release ova. Follicle stimulating hormone. Stimulates maturation of follicles so that they form ova into ova. But apart from that, they also bring about, follicle stimulating hormone brings about development of secondary sexual characteristics. Secondary sexual characteristics. Another hormone is luteinizing hormone. Abbreviated LH. Luteinizing hormone, again, this one is for release of the ova, stimulates release. Of ova, if it is one ovum. That process of releasing ovum from the ovaries when follicles have matured is called ovulation. Now, when we shall be looking at the menstrual cycle, you realize that this process is important. Ova must be released into the fallopian tube. That process of releasing is under the influence of luteinizing hormone. We call it ovulation. When ova is released and it meets the sperm, there will be fertilization. Then other hormones include ADH. We have come across ADH. ADH means anti-diuretic hormone. Antidiuretic hormone is important in it enables the kidney tubules to reabsorb water so that now it is involved in regulation of water, which brings about osmotic balance. Enables kidney tubules to reabsorb water. So in this process, it is able to bring about osmotic balance. So we have several hormones released by pituitary glands. We are going to mention nearly all of them. We also have a hormone called prolactin, number 6. Prolactin. Prolactin. So lactin is coming from milk. So prolactin stimulates mammary glands to secrete milk. to secrete milk. So you'll realize that the hormone will play a very important role during lactation period, especially when the baby is just newly born and he cannot suck very well. Prolactin will be involved so that it stimulates mammary glands to secrete milk in those alveolar spaces of the mammary glands or the breasts. And in the process, the baby, when the baby sucks, he can obtain the nutrients. And then the last hormone is oxytocin. Oxytocin is secreted by pituitary gland, and oxytocin is very important during birth. Before the baby is born, the uterus, after 9 months, the uterus will produce a rhythmic contraction. Those rhythmic contractions are important to expel the fetus out of the uterus. Now, for that one to happen, oxytocin will be released to the endometrium of the uterus, and endometrium will respond by producing a rhythmic contraction, and in the process, during contraction, the baby is pushed out of the womb or the uterus. So stimulates the endometrium to produce rhythmic contraction. Rhythmic contractions, and those contractions are important for or during birth. For birth process. Now, so from this, what we have just seen about pituitary gland, you realize that most of the time is stimulating other glands. Adrenocortical tropic hormone, stimulating adrenal gland to release adrenaline, aldosterone, that is, and adrenaline hormone. We have looked at thyroid stimulating hormone, stimulating thyroid gland so that it can secrete now thyroxine hormone. So in most of the cases, we are seeing pituitary gland releasing a hormone which then activates or stimulates another gland so that it can now release the hormone that will change or that will bring about change in activity. So for that purpose, you realize that pituitary gland is also given another name. It's called the master gland. Master gland. It's a master gland because it secretes hormones. Those hormones will now stimulate other glands which will release hormones. And then those hormones will change or control activities of the target cell. So it's a very important gland for purpose of coordination and controlling activities of body systems. We can look at another gland, number 2. We have thyroid glands. Thyroid gland. Thyroid gland usually secretes 2 important hormones. We have thyroxine hormone. Thyroxine hormone. Thyroxine hormone majorly controls metabolism in the body. In other words, it controls the rate of metabolic reactions in the body. Controls rate of metabolic reactions. Controls the rate of metabolic reactions in the body. We have another hormone secreted by thyroid gland called calcitonin. Calcitonin lowers the level of calcium in the blood. Level of calcium in the blood. So we are going to have several of them. We are going down. Gland number 3 is adrenal gland. Adrenal glands. Adrenal gland. This one releases a hormone, adrenaline. Adrenaline. This hormone has been classified as a hormone for fight or flight. A hormone that controls, it is for fight or flight, in quotes. So how does it bring about fight or flight? This is a hormone that is produced when somebody is anxious or when you are frightened, something like that. So why is it that when you are anxious, you want to sit for an exam? This is the hormone that would be released. Maybe you have seen a dangerous animal creeping into your home, like a snake, a python. Adrenaline hormone is going to be secreted by adrenal glands. So how does it bring fight or flight? Fighting means you are ready to defend yourself, and flight means you can run away. If you see a lion approaching you and you are not ready, if you are not a Masai Moran from Kenya, you are not ready to fight it, you are going to run away. For you to run away, there are several things that must happen. You are going to run away due to increased contraction of skeletal muscles. For that to happen, there must be energy. For energy to be there must be glucose being well supplied to your tissues, skeletal tissues, and also oxygen being well supplied. For oxygen to be well supplied, the breathing system must also change. That's why there will be a deep breath. The rate of blood circulatory, the rate of blood transportation or circulatory system is also going to change. So it is going to do that in several ways. So one of them is by increased heartbeat. Increased heartbeat. Increased heartbeat is important so that more blood is pumped to the skeletal muscles. When more blood is supplied to skeletal muscles, then it follows that you are going to have more glucose, more oxygen being provided to the muscles for you to enable you fight the situation or for you to run away. And also we are going to have blood pressure is also going to increase. Blood pressure increases for obvious reason due to increased heartbeat. We can also have constriction of blood vessels in the stomach region, so that now most of the blood is concentrated into the skeletal tissues. Constriction of blood vessels. In the gut region. In the gut. Why? So that more blood flows to skeletal muscles. Remember, for purpose of providing glucose and oxygen to increase the rate of respiration, so that now the body is ready to fight or to enable you run away. Number 4, pancreas. So before I say anything about pancreas, you remember that we encountered pancreas in digestive system. We said pancreas is able to secrete or secretes some juice. That juice, we called it as pancreatic juice. Pancreatic juice, the composition included having enzymes. One of the enzymes, pancreatic amylase, pancreatic lipase, pancreatic trypsin. And again, we are looking at pancreas as an organ or as a gland that secretes hormones. So pancreas usually plays a dual role, dual purpose, two purposes, either as a digestive organ or as an endocrine gland. It could be a digestive, it's a digestive organ, and also it is an endocrine gland. So that's why we are referring to pancreas as a dual organ. So someone can ask you to briefly explain why the pancreas is a dual organ, because it is important in digestive system, also in the endocrine system. In digestive system, it releases enzymes. We have found out the enzymes. In the endocrine, as an endocrine gland, it secretes hormones. We are going to look at those hormones. So we have two hormones that are secreted by pancreas. We have insulin and glucagon. But before we look at glucagon, let us briefly look at insulin. We have come across insulin several times. So the major role of insulin is to lower blood sugar back to normal level. Lowers blood sugar back to normal. How does this happen? We have mentioned this several times. Through conversion of glucose to glycogen. Converting glucose to glycogen. This glycogen is stored in skeletal muscles. That's why even for adrenaline, again, we did not mention that. Adrenaline, when adrenaline hormone is released, when you are anxious, when you are afraid, it also helps in reversing this process, converting glycogen back to glucose, so that now you have more glucose in your blood to enable you fight and run away from danger. And then another way is going to lower blood sugar to normal is by converting glucose into fats. So these fats will not just be circulating into the bloodstream, but they'll be stored. They'll be stored in form of adipose, as adipose tissue. As adipose tissue. And then you can also remember that we have mentioned that when blood sugar is too high, insulin will cause the liver cells to increase oxidation. So it causes increased oxidation. Increased oxidation. Increased oxidation of glucose. Another hormone is glucagon. Glucagon. Glucagon is antagonistic to insulin. In other words, it reverses the roles or the effect of insulin. It will be in opposite direction. Now, we have said insulin lowers blood sugar to normal. So antagonistic effect of glucagon shall be increases blood sugar to normal. Glucagon raises blood sugar to normal. Now you can remember the normal that we have been talking about, 70 milligrams to 90 milligrams of sugar in 100 ml of blood. So in other words, every 100 ml of blood that we shall take for sampling, we expect to find the normal of 70 to 90 milligrams of sugar. If we are going to have anything above 95, 100 milligrams of sugar in 100 ml of blood, then that is too high. That's when pancreas will be stimulated to secrete insulin. Insulin will cause liver cells to do the following: convert glucose to glycogen for storage, glucose to fats for storage, increase oxidation. But now we are saying we have another hormone, glucagon. They are not going to be secreted at the same time. When this one is released, it means glucagon cannot be released because there's no condition that is now causing or that is forcing or compelling pancreas to secrete glucagon. So glucagon is secreted mainly when blood sugar is below normal. So it is going to raise it back to normal. Insulin is secreted when blood sugar is too high. So it's going to lower blood sugar back to normal. So glucagon raises blood sugar to normal. How? By causing liver cells. It does not do it on its own. It causes liver cells. Liver cells are the effector. Just like we have looked at the pathway, liver cells are the one that will respond to glucagon, are the one that will respond to insulin. So it will cause liver cells to convert glycogen to glucose. Convert glycogen to glucose. It will again cause the liver cells to convert fats in the adipose tissue to glucose. Fast to glucose. And then the last antagonistic effect, increase. So it causes decreased oxidation of glucose. It will cause liver cells to decrease oxidation of glucose. So in this way you can see that glucagon is acting in antagonistic manner to insulin. It is an antagonist to insulin, and the two are always acting in the opposite direction. Gland number 5, there are several glands. We have ovaries. Ovaries secrete two major type of hormones. So again, something about ovaries. Ovaries are found in the reproductive system. They are meant to produce ova. But as they do that, they also secrete hormones. So they also have dual roles. So one of the hormone is called estrogen. Estrogen. Estrogen is the one that leads to development of secondary sexual characteristics, specifically in females. Development causes development of female secondary sexual characteristics. So when a baby girl is born, some of the features that appear in adult female will not appear in a baby girl. For instance, breasts. Breasts usually develop at puberty. Development of breasts. This one only comes at puberty and is a secondary. Primary, we know all the features. So secondary sexual characteristic. An example is development of breasts is under the influence of estrogen. Now, look at this situation. Suppose we have a baby girl of 5 years or 3 years, and then maybe a problem happens and the ovaries are removed at that early stage. There will be impairment in the development of some of the secondary sexual characteristics. Like, she's not going to develop the breasts because estrogen is produced by the ovaries. And ovaries, when estrogen is not there, then we do not expect development of these sexual characteristics, like development of the breasts. So it's important that it should be there. And then also controls menstrual cycle. Controls menstrual cycle. Another hormone produced is called progesterone by the ovaries. Progesterone. Estrogen is produced in a cyclic manner every month in every menstrual cycle. Progesterone is mainly produced when a female human being or a female mammal is pregnant. So the role of progesterone is mainly to maintain pregnancy, maintains pregnancy. Maintains pregnancy. So how does it maintain pregnancy? There are two ways in which progesterone will maintain pregnancy: by causing thickening of the endometrium. Endometrium is that inner layer of the uterus. It has to be thick so that now we are going to have implantation of the fetus and then of the zygote. That is, after implantation of the zygote is now called the embryo, and the embryo develops into the zygote. And then another way in which it's going to maintain pregnancy is by increasing blood vascularization, increases blood capillaries, causes increased vascularization. Vascularization means high supply of blood capillaries. So there will be increased blood capillaries. Increased blood capillaries in the uterus. Why should we have this? Remember, at that time, the baby is developing, it needs nutrients, but it's not feeding directly. So whatever the mother feeds on shall have to go to the fetus for its development, or the embryo for its development. Now, to reach that achievement, we must have high supply of blood capillaries in the uterus or in the endometrium, so that now the baby or the fetus can obtain nutrients, can obtain oxygen, and can also, when it releases waste metabolic products, are taken away at a faster rate. So I think for this lesson, we are reaching the end. After another 1 hour, we shall continue with the glands, hormones, and their function. Thank you.